This video supports the notes for section 5.12. We're now beginning to solve polynomials. And the first thought, and we will discuss this further in class, but in order to lay the foundation for what's trying to be presented here, I do need to discuss what's called the zero product property, and it's an if-then statement. If A is 0 or B is 0, then the product of AB, when I multiply those two numbers together, the product is also 0, which we've been studying on and off all year. But if either factor is 0, when I multiply the two factors together, the entire product is 0. Roots are just simply solutions or values that make the equation true. These are solutions, and we'll discuss that more in class. Solutions are values that make the equation true, and that's something that you're already familiar with. The fundamental theorem of algebra, we've talked about this slightly. Now we're actually going to use it. A poly of degree n has at most n real number solutions. And we'll discuss that more in class as well. Real number solutions or roots. So if either factor is 0, the entire product is 0. That's your zero product property. Roots are just simply solutions or values that make the equation true. The fundamental theorem of algebra says if I have a polynomial of degree 2, that means I can have at most 2 real number roots or solutions. And we'll discuss graphically what the roots mean. We'll discuss that whenever we meet together as a class again. Looking at some of the examples, let's discuss exactly what we're going to do. Whenever we're solving these, we need to put the equation in standard form and set it equal to 0. Setting it equal to 0. Then you factor the polynomial that you're looking at. And then the way you solve it, you set each individual factor equal to 0 and find the value that would make each individual factor 0. The values that you get comprise your solution set or your roots. So let's go through some of these examples together to show you how this works. The first example, it's already factored for you, so there's no need to multiply this out. I can see that the individual factors for this polynomial are x plus 4 and x plus 9. So I simply take each individual factor and set it equal to 0. So that means that my solution set for number 1 would be negative 4 and negative 9. If I were to multiply this out, I see that the first term I get is x squared. So that means that this is a degree 2 quadratic, meaning that I can have at most 2 roots or solutions, which I do. Negative 4 and negative 9 are both solutions to number 1. Let's look at number 2 together. Number 2, once again, is already factored for you. So you just simply take each individual factor, set it equal to 0. So you can see that if I multiply this out, the first term I get would be x squared. So that means that this is a degree 2 polynomial, which means I can have at most 2 real number solutions. So my solution set for number 2 is a value of x equals negative 3 or x equals positive 4. A degree 2 equation with 2 possible solutions. Looking at number 3, it's already factored for you once again, so you just simply take each factor, set it equal to 0, and you can see that your first solution is negative 5, your second solution is positive 5. So once again, x times x gives you x squared, meaning you have a degree 2 polynomial, so your solution set would have at most 2 real number solutions, and the most efficient way to write this solution would be to use the positive negative symbol, and that implies that the solution set for this quadratic would be positive or negative 5. Okay, let's move on to a few other problems. Number 4 is not factored for you, and in fact it's not even set equal to 0. So the first thing you need to do is set this equal to 0. And by doing that, that means you would add 24 to both sides. So step number 1, set it equal to 0, arrange it in standard form, and then factor it. So I need factors of 24 that sum to negative 10. So that means I would have x minus 6, x minus 4. I take each individual factor and set it equal to 0. So that means my solution set for number 4 is positive 4 and positive 6. So I have a degree 2 quadratic. That means I can have at most 2 real number solutions. Moving on to the next problem. Well, it's already set equal to 0. It's arranged in descending order. I analyze to see if there's a GCF, which there is. If I remove 3x, what remains behind is x minus 6. And this is an equation, so you should always set it equal to 0. Then I take each individual factor and determine which value would make that particular factor 0. Here, if 3x is 0, that implies x is 0. And then over here, x is positive 6. So I started with a degree 2 polynomial. The fundamental theorem of algebra tells me that I can have at most 2 real number solutions. 0 and 6 are both real numbers, and they are my solutions. Number 6 is a little trick. Oftentimes students want to divide away the 2 or divide out an x. That's not the correct way to do this. You need to set it equal to 0 by subtracting 50x from both sides. Don't try to divide any factors out. If you do that, you will miss some of the roots. So here I have a degree 3 equation, which means I can have at most 3 solutions. So the first step in factoring, once you've arranged it in standard form, and now we're solving, it's in standard form set equal to 0. Now it's time to factor. So factoring step 1 is look for a GCF. Here I have the GCF of 2x, and then what remains behind is x squared minus 25. The second step in factoring, once you remove the GCF, look for a difference of squares, which you have here. So this is x plus 5, x minus 5. And now I have the 3 factors set equal to 0. So I have to find the value that makes each factor itself 0. If I set 2x equal to 0, that means x itself would be 0. If I set this factor equal to 0, that means x would be negative 5. X would be negative 5. And for this factor, x would be positive 5. So my solution set for number 6 is 0 and both positive and negative 5. That's 3 real numbers, 1, 2, 3, for a degree 3 equation. Looking at number 7, it's already factored for you, so take each individual factor, set them equal to 0. Here I would add 3 first, and then divide by 2. So 1 root is 3/2. Here I would add negative 5, then I divide by 3. So my 2 solutions for number 7 are positive 3/2 and negative 5/3. A degree 2, my first term would be 6x squared. It's a degree 2 poly, which means I can have at most 2 real number roots. Let's look at number 8. Number 8, well, it's not set equal to 0, so that's step number 1. X to the 4th minus 5x squared plus 4 equals 0. Then factor this. I need factors of 4 that sum to negative 5. So that would be x squared minus 1, x squared minus 4, negative 4 plus negative 1 plus negative 1, negative 1 plus negative 4 is negative 5, and negative 1 times negative 4 is positive 4. Now, I'm going to let you factor this on your own. I'm starting with a degree 4 polynomial, so that means that my solution set could contain 4, at most 4 solutions. And this does, and I will let you factor this on your own. And then let's look at number 29, or excuse me, number 9. So number 9, a few things going on. It's not set equal to 0, so I can't just subtract 28 from both sides in the state that it's in. So let's multiply the factors that we have. I have x squared minus 7x plus 10 equaling 28. Now I subtract 28 from both sides. Now I factor this. I need factors of negative 18 that sum to negative 7. So that tells me I'll have x minus 2 or x minus 9 times x plus 2. and then it's easy enough to pull my two solutions out here. X would be positive 9 here, X would be negative 2. So when I multiply, my first term is a square, it's a degree 2, meaning that I can have at most 2 real number solutions.